So far, we have learned about a pair of linear equations in two variables. In this video, we will learn about graphical method of solving a pair of linear equations and the behavior of the lines denoted by a pair of linear equations. Can you tell me, what is the geometrical representation of a linear equation in two variables? Absolutely right. This is a straight line. Each solution of this linear equation is a point on the line denoting the equation. So we can say that a pair of linear equations in two variables will denote a combination of straight lines in geometrical form. Hope you remember our previous video in which Rahul created a pair of linear equations in two variables to find the number of balloons and ice creams he bought on his birthday. Now he wants to know the number of balloons and ice creams by solving this pair of equations. Let's help Rahul. To find this, in both the equations, for some values of x, find the corresponding values of y. Plot these points on a graph paper to get a pair of straight lines. Both these lines intersect at the point 7, 12, which is the only common point for both the lines. Therefore, x is equal to 7 and y is equal to 12 will be a solution for this pair of equations. Since the point 7, 12 is a common point on both the lines, this is the only solution for the given pair of linear equations in two variables. Therefore, Rahul bought 7 balloons and 12 ice creams. In this example, you saw two straight lines intersect each other at one point. Can you think of two straight lines in one plane in any other position? We know that if there are two lines in one plane, then those lines are either intersecting or coincident or parallel. These three conditions can be represented for a pair of linear equations in any two variables as follows. If the ratio of the coefficients of x in the pair of equations is not equal to the ratio of coefficients of y, the lines denoted by the pair of equations will be intersecting lines. In this case, the solution to the pair of equations is the unique solution. If the ratio of the coefficients of x, the ratio of the coefficients of y, and the ratio of the constant terms are equal, then the lines are called coincident. In this case, there are infinite solutions for the pair of linear equations. And if the ratio of the coefficients of x and the ratio of the coefficients of y are not equal to the ratio of the constant terms, then the lines are parallel lines. In this case, there is no solution for the pair of equations. So, we can say that a pair of linear equations that have a common solution is called the consistent pair of equations. And a pair of linear equations that has no solution is called the inconsistent pair of equations. Today, we studied the graphical method of solving a pair of linear equation and the behavior of the lines denoted by the pair of linear equations. In the next video, we will see some interesting examples based on them. In our previous video, we studied the graphical method of solving a pair of linear equations in two variables. Today, in this video, we will see some examples based on the graphical method of solving a pair of linear equations in two variables and the behavior of the lines denoted by the pair of linear equations. Solve the given pair of linear equations using the graphical method. For the given pair of equations, in each equation, for the value of x, take the corresponding value of y and plot them on the graph paper to obtain two simple lines. You can see that these two lines are coincident lines. Can you tell what this means? This means that the pair of equations is a dependent, consistent pair. So this pair of linear equations will have infinite solutions. Now let's see another example. How many solutions can be there for the given pair of linear equations? 2x plus y equals to 6 and 4x plus 2y equal to 5. How will we find it? Can you find any relation between the coefficients and the constant terms of the given equations? Let's compare the equations with the general form of linear equations in two variables. We can see a1 is equal to 2, b1 is equal to 1, c1 is equal to minus 6, a2 is equal to 4, b2 is equal to 2, and c2 is equal to minus 5. We see that here a1 divided by a2 is equal to b1 divided by b2, but that is not equal to c1 divided by c2. In the previous video, we studied the behavior of the given lines of a pair of linear equations, according to which we say that the given linear pair represents parallel lines which have no solution. Can you tell if the given pair of equations is consistent or inconsistent? Because this pair of linear equations does not have a solution, it is an inconsistent pair of linear equations. Today, in this video, we saw some examples based on the graphical method of solving a pair of linear equations in two variables and the behavior of the lines denoted by the pair of linear equations. In the next video, we will see a few common mistakes that can occur while solving these types of questions. In the last video, we have studied the behavior of lines denoted by a pair of linear equations in two variables. Now, we will look at some of the commonly made mistakes based on this. How many solutions will the line denoted by the pair of equations 6x minus 3y is equal to 15 and 2x minus y is equal to minus 5 have? Pause the video and try to solve this question. Now, by comparing our equations with the general form of linear equations in two variables, you can see that a1 by a2 is equal to b1 by b2, which is not equal to c1 by c2. In this case, the lines denoted by these equations will be parallel to each other. Hence, there is no solution. As a result, option 3 is the correct answer. If you had chosen option 1, then it's a good try. But this is an incorrect answer. Because in order to have one or a unique solution to a pair of linear equations, the ratio of their coefficients should not be equal. Which is not true in this case. Hence, option 1 is incorrect. If you chose option 2, then it's also a good try, but it is also incorrect. Because while comparing our equations with the general form of linear equations in two variables, we forgot to prefix the constant term of the first equation with a negative sign. And as a result, the ratio of coefficients and the ratio of constants turned out to be equal, and we got an incorrect answer. In the class, a teacher can test the knowledge of her students using such examples.